in store for us. It goes like this. A circle of 50 mm diameter rolls on the circumference of another circle of 175 mm diameter and outside it. Alright. Trace the locus of a point on the circumference of the rolling circle for one complete revolution. Name the curve. Draw a tangent and normal to the curve at a point 125 mm from the center of directing circles. Now guys, this particular problem is associated with cycloidal curves. First thing is you need to identify the rolling circle, and this is the rolling circle having a diameter of 50 millimeters. And there is also a directing circle having a diameter of say 175 millimeters. The next thing to identify is, where is this rolling circle rolling? It's rolling outside the directing circle. That is a clear indication that the curve generated is going to be an epicycloid. So let's write down this condition initially. Circle rolls on and outside the directing circle for one complete revolution. So we have this rolling circle diameter 50 mm and we have this directing circle diameter as 175 mm. So the radius of rolling circle is going to be 25 divided by 2, and the radius of directing circle is going to be 87.5. That is 175 divided by 2 will give you 87.5. Now guys, just think about this. When this rolling circle starts rolling and completes one revolution, some kind of an angle is going to be subtended at the center of directing circle. How much that angle is, that can be computed with the help of this formula. 360 into small d over capital D, it's going to be equal to 102.8 degrees. So this 102.8 represents the sector of a directing circle, above which there is going to be a rolling circle that's going to roll. Alright, so let's get started with the construction aspect of this particular problem. Alright, so we've made a point. Let's say the name of this point is O, and this is what you call the center of the directing circle. The entire directing circle is not to be made, rather a sector that is 102.8 degrees is going to be made. Okay, so this line that I have drawn, it represents the radius of the directing circle having a magnitude of 87.5. Fine. So let us have a protractor over here. Okay, now the angle subtended over here is going to be 102.8. so this is the 0 mark. From here you need to go over here. 90, 100, 102.8 is going to be something. 102.8 is going to be lying somewhere here. So you guys can take it approximately as 103 degrees, because 102.8 degrees is not possible for humans. Only Rajnikant can do so. Anyway, let's have the line 102.8 degrees. Fine. So let's remove this protractor. Alright, let's start again. This is 102.8 degrees, this is 87.5, and this is the point P which we'll be keeping a track on, and above which we'll be making this rolling circle. Let's draw this. So okay, you can produce this line, and this distance is going to be 25 millimeters. Okay, and this automatically qualifies as the center of the rolling circle. Fine. So let's have a rolling circle. Alright. Now perpendicular to this line we have this line over here, and perpendicular to this line we're gonna have one more line, and let's move ahead this way. So you can clearly see that this rolling circle automatically has been divided into 4 equal parts. So 4 parts, pick say one part, right, and divide this into 2 equal parts. Divide this also into 2 equal parts. In such a way, when you divide each and every sector over here into 2 equal parts, you're gonna end up having circle divided into 8 equal parts, something like this. Alright, fine. Now I'll do the numbering portion 1, 2, 3 in the anti-clockwise sense. There is a specific reason why I've done the numbering in such a way. Alright, now let's have the arcs with O as center and with OP as radius. I'm going to draw an arc right now, something like this. So this rolling circle is rolling in the clockwise sense, and with O as center and with O7 as the radius, I'm going to make an arc here again. Now with O6, this is the center, and with O6 now, with O5, with O4. Alright, so these are the arcs. Fine, let's move ahead. Now just guys think about this. If we have a rolling circle over here, it starts to roll in the clockwise sense. This point over here will come into contact above this surface. Okay, so this point comes into contact initially. After this point is going to come in contact. That's why this has been named as 1, this has 2, and then so on, 3, 4, 5, 6, 7, and finally we have point B. Fine. Alright, so circle has been divided into 8 equal parts. Arcs have been made from all these points, and the next thing to do is, when this circle will start to roll and complete its one revolution, you should realize this, all these points are going to make an impression over here. Like 1 point is going to make an impression here, point 2 is going to make an impression here, 3, 4, 5, 6, 7, and finally P. So you should realize that this surface over here, this arc over here, will get divided into 8 equal parts, and that's exactly what we're going to be doing right now. Okay, so this angle is 102.8. So let's draw an arc, something like this. Okay, you can see this arc. Let me draw it once again. Okay, of any suitable radius with OS center, draw this arc. Now with this extreme point as the center, you need to put an arc, and with this extreme point as the center, you again need to put an arc, something like this. Okay, so this is the intersection point. Okay, now so this angle has been divided into two equal parts, so 2 can be made 4. All right, so keep your compass here, put an arc, keep your compass here, cut that arc. It's going to be looking something like this. All right. Okay, same stuff has to be repeated with this as the center and with this as the center. Okay, with this as center, you need to make an arc. With this as center, you need to cut this arc. Alright, now you can clearly see that this angle 102.8 degrees has been divided into 4 equal parts. Okay, so initially there was only one angle, 1 was made into 2, 2 was made to 4, and now what we're going to do is 4 can be made to 8. Alright, so let us say we have this angle over here. Okay, so keep one leg of your compass here, okay, and make an arc, okay, and then with this as center, again make an arc, something like this. So this is the intersection point. Same stuff has to be repeated in this section also. Okay, with this as center, put an arc, with this as center, cut an arc, something like this. Alright, same stuff here also with this as center and with this as center. Again, we need to repeat the same step over here also. This as center and this as center. Alright, so we have all these points, okay. Now, the next thing to be done is, so this is the initial center position, this is going to be center position at 1, center position at 2, and so on. Okay, likewise I've written them down. Alright, now when C point was here, P point was here, so when C point is going to change its position, let's say circle rolls along this surface and C0 becomes C1. So what you need to do right now is we need to keep your compass set at a radii of 25 millimeters. And this arc you see passing through point 1, you need to take this as the center, C1 as the center, and you need to put an arc over here, something like this. And this is going to be your point P1. Okay, same step has to be repeated for C2. Let's say we take C2 as center, this point as center, and this is the arc passing through point 2, alright. And with C2 as center, you need to cut an arc over here. So that is going to be your point P2. Similarly, for C3, we have an arc passing through 3. Okay, so C3 as center, you need to put an arc over here. So this is going to be point P3. Alright, for C4, we have an arc over here. Take C4 as the center. You again need to make an arc. This arc is not going to intersect anyone. Alright, it's going to just touch this, something like this. Let me show you how. That's it. That's it. That's point P4 for you. Alright, now we have C5. So we've got to make sure that this arc passing through 5, this arc passing through 5 should be intersected. With C5 as center, you need to again put an arc over here. So this is going to be P5, C6 as center, and this is the arc through 6. Alright, so with C6 as center, you need to put an arc over here, somewhere here. That's point P6. Fine. So this is the arc through 7. Alright, and with C7 as the center, you need to make an arc over here. This is P7, and finally we take C8 as the center. The arc is just going to touch this. Alright, and this is going to be point P8. Fine. Now when we join all these points in sequence, you're going to have the curve generated, and which is popularly known as an epicycloid, right? That's it. That's what you call an epicycloid. Now guys, there was one more thing in this problem, that we are supposed to make put a tangent and normal at a certain point 125 mm from the center of the directing circle. So guys, this over here, this is the center, this is the directing circle guys, and this is the center of the directing circle. So with O as center and with a radii of 125 millimeters, we need to put an arc taking O as the center. Alright, so this is the arc. Okay, so this particular arc is intersecting this epicycloid over here, and hence you can say that this point is at a distance of 125 from this O. Okay, this point. Now let's say this point is named by Q, and with Q as the center, and somewhere along this center arc, you see, okay, we are going to put an arc yet again, and that's going to be having a radii of 25 millimeters, small r. Small r corresponds to the rolling circle radii. Alright, so with Q as center, I'll put an arc over here, something like this. Okay, so this point I'm talking about. So this is S, and the next thing to be done is to join S with O. Alright, and on drawing this line, you should have realized that this surface was intersected somewhere here. I mean the surface on which the circle is rolling. Alright, so this intersection point, let's say this name of this intersection point is M, and when you join M with Q, you're gonna have a normal. Alright, and line perpendicular to the normal passing through Q is going to be what you call a tangent. So guys, that was all from my side. This is Manas Patnaik signing off. I'll see you again for problem number 3, which is going to be based on hypercycloid. Until then, it's a wrap, and have a great day.